Welcome to this explainer. Have you ever looked at a problem in your house, your garden, or even just your daily routine and wondered how to actually solve it without just blindly guessing? Well, today we are going to demystify the scientific method. People often hear scientific method and immediately picture folks in white lab coats mixing complex chemicals. But really, as we're going to see today, it's just a structured, completely foolproof recipe for everyday discovery. It's the ultimate tool for anyone wanting to turn their random curiosity into hard facts. So, let's dive right in. To really ground this, we're going to use one super relatable mystery as our main case study throughout this explainer. Does the amount of sunlight affect the growth of mungo seedlings? It's a fantastic, really straightforward question. Maybe you're trying to figure out where to place your indoor houseplants, or you're planning a little backyard garden. Whatever it is, having a concrete example like this is going to show us exactly how this method works in the real world. To solve this mungo seed mystery, we'll just follow these 5 steps: aim or problem, materials and equipment, method or procedures, results and data, and step 5, the final conclusion. Kicking things off with step 1, aim or problem.
So, what is an aim? It's literally the main question of your entire journey. It tells you exactly what you're investigating. Our aim here is to discover if the amount of sunlight affects mungo seedling growth. And the absolutely crucial word to remember here is testable. Plant growth is something we can actually observe and measure with a ruler. If your question isn't testable, you really can't apply this method.
Here are some quick tips for nailing that aim. Try starting your question with does, how, or what happens if, and listen, you've got to focus on just one main problem at a time. If you try to test sunlight, watering schedules, and soil quality all at the exact same time, you'll never know which one actually caused the plant to grow better. Your aim is the true north of your investigation, so you want to keep it laser-focused.
Moving right along to step 2, materials and equipment. Now we actually gather our supplies. You've got materials, which are the things you use up, and equipment, which are basically the tools that help you measure. For our experiment, we need exact quantities of some pretty simple everyday items: pots, seeds, soil, water, and a ruler. The trick is to write down the exact numbers and amounts before you even begin.
Now, the absolute key here: keep it fair. Why are we so obsessive about using the exact same size pots and the exact same kind of soil? Well, preparing your materials beforehand ensures your setup is totally organized and completely unbiased. Think about it. If one pot is massive and filled with premium fertilizer and another is tiny with terrible soil, your results are going to be completely skewed. Fairness guarantees your final answer is actually reliable.
Next up is step 3, method or procedures.
This is where you write out your step-by-step instructions. You want to use clear, direct action words, so literally anyone could repeat your test perfectly without having to ask you questions. The golden rule for your method: change only one factor at a time while keeping everything else exactly the same.
Let's see how this actually works for our mungo seeds. Step 1, put the same amount of soil into 3 pots. Step 2, plant the same number of seeds in each. Step 3, water each pot equally every single day. Step 4, place 1 pot in little sunlight, 1 in some, and 1 in lots of sunlight. And finally, step 5, measure the height daily and write it down. Notice what we did there? Sunlight is the absolute only variable we're altering across our 3 pots. We kept the soil, the seeds, and the water identical. And that is how you set up a flawless scientific test.
Now for the fun part. Step 4, results and data.
Okay, this step actually requires some serious discipline. It's strictly about gathering your observations and jotting down those measurements using the correct units, which is centimeters for us. The rule of thumb here is to write down only what you observe, ideally neatly organized in a table or graph. Do not start guessing why things are happening just yet. You have to save those personal theories for the very end.
After 5 days, when we plot our recorded data, the pattern is just undeniable. The seedling with little sunlight grew to 4 centimeters. The one with some sunlight hit 6 centimeters. And the seedling with lots of sunlight, a full 8 centimeters. By laying out the results like this, we aren't just guessing anymore. The pattern is perfectly clear right in front of our eyes.
Which brings us to step 5, the final conclusion.
This is the grand finale. It's where you look back at your original aim, summarize your key results, and finally answer your question based on the hard evidence. So, looking back at our mungo seeds, we can confidently state, yes, the seedlings that received more sunlight absolutely grew taller than the rest. We just clearly stated what we learned, and it's completely backed up by the measurements we took. Boom. Mystery solved.
Here is the biggest takeaway from this entire explainer. A good conclusion is always based on data. It is not just an opinion. When you write up or talk about your findings, actively use phrases like based on the results or based on the data. If someone asks you why you think plants need sunlight, you don't say, I just think so anymore. You say, based on the results of my investigation, plants with more sunlight grow taller. It completely shifts you from being just a guesser to being a real investigator.
And there you have it. You now have the exact 5 steps to turn a random passing curiosity into concrete, undeniable evidence. Aim, materials, method, results, and conclusion. The scientific method isn't just for fancy laboratories. It's a surprisingly powerful tool you can use to discover the truth right in your own backyard. So, armed with this foolproof recipe for discovery, what everyday mystery are you going to solve next?